Hey guys, what is up? It's your pal Dave from notesandvolts.com, and I'm here with a new kind of segment program that I'm trying out. It's called Dave Makes Your Dreams Come True. I'm sorry about the logo. I'll work on it. It's going to be better, I promise. But think of this as Fantasy Island for electronics, and I am your Mr. Rourke. For you younger viewers, Ricardo Montalban, just Google it. So I get a ton of emails and they all kind of follow the same pattern. How do I modify your tutorials to do this very specific thing that maybe only I need? It will control a very specific piece of gear or work in a strange way. And usually I don't have a lot of time to answer, because really the only way to answer how to modify code is to modify the code, and that takes a lot of time. So I thought what I could do is just pick some random ones and just do it. I will modify the code, I will build up the circuit, I will show you how to do it, and hopefully make your dreams come true. So the other day I get an email from someone named Hank, and he says, "Hi Dave, I found your YouTube video while researching how to build my own switch. I was planning on buying a Morningstar MC3, I'm not sure what that is exactly, but they're having supply chain issues." Yes, aren't we all? Actually, I'm glad, because I love building stuff and I never knew building MIDI stuff was possible for a DIYer. Oh, it's very possible. I want to make the freeze infinite function on my Strymon BigSky to be latching instead of having to hold down the foot switch on the pedal. I've learned that sending CC on 97 will do this. 127 turns it on and 0 turns it off. I also want to switch between the freeze and infinite functions. Sending CC70 does that. 0 is freeze, 1 is infinite. Would I need 4 switches to do that? Also, is there an adapter that goes from USB MIDI to standard 5-pin MIDI to connect to the BigSky? Thanks for your help and your video, Hank. Well, Hank, thank you very much for your email. You actually did a great thing. You did some research and you found out exactly what you need, the exact CC numbers and the exact conditions that you need to program into your pedal. And that is very helpful. As for your questions, do you need 4 foot switches? I think we can do it in 2, and I'm going to show you why. Also, is there an adapter that goes from USB MIDI to 5-pin MIDI? Well, I'm sure there is, but I think you saw my tutorial on how to build a MIDI foot switch, which was a USB MIDI device. But since you need 5-pin, we're going to actually build a hardware 5-pin MIDI into our pedal, so we don't need any adapters. So now that we know what we're doing, let's get started. And hopefully, Hank, I'm going to make your dreams come true. All right, Hank, let's do some designing. This is my idea. So I'm going to design this around one of these boxes. This is a Hammond 1590 BB. I think BB stands for beautiful box, but don't quote me on that. But anyways, these guys are great for guitar effects. This is unfinished, but you can get them in real fancy colors if you want. So we're going to use this as our kind of guideline as far as sizing goes. Now we'll take 2 switches. These are normally open, so that means when they're not pressed, this is disconnected, and when you press it, these 2 terminals connect. These are called single pole, single throw. That means there's only one way to push it, and there's only one set of connectors. And these are also momentary, which is very important. So you can get latching switches, so you push it once, it's on, you push it again, it's off, like a light switch. But these ones, on, and when you release it, they go off immediately. So you want these type of switches. I like these little right angle ones because they fit nicely in the box. Okay, so we'll take a couple of those. We're going to need MIDI out, so we'll use maybe one of these panel mount MIDI jacks, and that will go on the back. And we also need power in, and we'll use one of these barrel connectors that you'd see on a guitar effect. I like these ones with the plastic shroud because they don't conduct to the box. So if you look at your power supply, it will have a tip, which is where this little pin goes, and a sleeve, which is the outer part of the plug. And you have to determine on your power supply, is the tip positive or is the tip ground? If the tip is positive, then wire it up one way. If the tip is grounded, wire it up the other way. So you just have to determine for your power supply which of these pins is positive and which is ground. All right. So what I was thinking is we're going to take the two switches and we can put them somewhere convenient like that. And basically this will be your mode switch. So we'll label that mode. And this will be your on-off switch. So like you said, there's two modes that you have to switch on your pedal, and then depending on what mode you're in, you want to be able to turn it on and off. So this will toggle between the two modes. So if you push it once, you're going to be in the freeze mode, and if you push it again, you'll be in the second mode. And then for each mode, you can turn it on and off if you push this switch. To let you know which mode we're in, we're going to put a little LED over here, and we'll put another one over here to let you know whether the effect is on or off. And I think that's going to be good. We only need two switches. We can make this very compact, and it's going to fit nicely on your pedal board. All right, so here is the schematic I came up with for this circuit. So for our processor, we're going to use a very cheap and simple one. It's called an Arduino Nano. So this is the 5-volt version. It may come in a 3.3-volt version, but since 5-pin MIDI is 5 volts, we want the 5-volt version. So there's our processor. There's our two switches. There's our LEDs. So there's not many parts in this. So we've got our Arduino Nano. We've got our two LEDs, the two switches, and we need 4 220 ohm resistors. And there's our power in jack. Here's our MIDI jack, and that's about it. Very, very simple circuit. So if you're new to schematics, here's something that beginners get confused with quite a bit. So of course the green lines are your connection. These are wires basically. So this shows you that this side of the switch is going to D2 on your Arduino, and the other side is going to a ground point. So ground on the Arduino can be either of these pins. They're labeled ground on the Arduino. But one thing to keep in mind, all these ground symbols, even though there's no wire between here and here, they are connected. It's just the way you do it in a schematic to make it not so busy. So just realize all these ground points are all connected to the same pins. Even this one here. And this 5-volt is actually connected directly to the 5 volts on the MIDI jack. So to build this circuit up, I'm going to build it on a temporary breadboard just so I can show you how to wire it up and how it all works. But when you want to make your finished one, something like this is very handy. This is called an Adafruit Perma Proto. And it's basically follows the same layout as your breadboard, but in a permanent version. So you can just take your circuit right off the breadboard, put it onto this, and install this in your case. It even comes with some mounting holes. So you can put some screws maybe through the top of your enclosure and some standoffs to keep the board in place, but there you go, something like that. All right, so we'll start by taking the Arduino and putting it somewhere at the edge of the board here, and gently but firmly press it into place. Next, we'll wire up the power and ground. Now for now, I'm going to leave the power alone because when I attach a USB cable to program this, it's going to power it itself. But the final version, we're going to use the external power jack for your pedal power supply. But we need to get the ground. Now, a handy thing, if you look on the back of these boards, you'll notice these strips at the bottom, they're all connected. So we can make this a power strip. So you notice one is blue, one is red. we'll just make the blue one, and it's the same on here. We'll make the blue one the ground strip. So this whole strip will be grounded. So to do that, we'll just take a little piece of wire, and I'll connect it. There's a terminal on here marked GND, and I'll take a wire and attach that to the ground strip. And that way I can plug a whole bunch of things into this ground strip, and they'll all be connected to this ground pin. Now, to make this easier to breadboard, I'm going to use these kind of micro buttons just for this temporary circuit, so it's a little easier to put in a breadboard than those big foot switches, but they work the same. And I'll just place them so they're straddling this middle part of the board. One side of the switch is going to go to this D2 pin on the Arduino, and the other switch, one side, will go to D3. So to do that, I'm going to use these little jumper wires. One side of the switch goes to D2, and luckily it's labeled on the Arduino right there, and the other one side of the switch will go to D3. Now, if you look at the other side of the switch, it's going to go to a ground point, which we've got connected to our ground bus, if you remember. So I'll take two little jumper wires, and I'll go take the other side of the button and put it to ground. There we go. And the other one. And there we go. Okay, now next we'll wire up our LEDs. So the LED is going to have a flat spot on it. Most of the time there's one side of the bezel that's kind of flattened, and that side is where this line is in the symbol. That is called the cathode, so that needs to go to ground. The other side will go to our D6 and D7 pins. In between that, we're going to put a 220 ohm resistor, and that's very important. This is called a current limiting resistor, and what it does is it stops the LED from blowing up, basically. Very important. So when the LED switches on, it's going to act like a short circuit, and the Arduino is just going to try to dump as much current as it can through this line to ground. So we have to put this, that's going to limit the current, so when the LED turns on, this will constrict the current and make sure nothing blows up. So in order to do this, we'll put it in two adjacent holes on the board. Okay, and then we will take two little pieces of wire, and we will connect the flat spotted side to the ground strip. Now we're going to grab our two 220 ohm resistors. So the marking on these should be red, red, brown. And we're going to go from the other leg. Let's take it up here across the middle. And this will go on the non-flatted leg of the LED, just like that. Now on the other side of our resistor, we're going to take the other leg and wire one to D6, one to D7. So that's our switches and LEDs done. All we have to do now is the MIDI jack. So when I'm breadboarding like a temporary circuit like this, I like to use these type of jacks because they fit nicely into the breadboard, so I can just kind of stick it at the edge here. MIDI jacks, for an out circuit, we only use 3 pins. This bottom one and the 2 adjacent. We don't use these outermost pins for anything, so you can leave those unconnected. So the middle pin on the jack is going to go to ground. So I'm going to use a piece of wire to jump it across the board. And then a second piece, if I had a longer piece, I could have done it in one shot, but we'll use two pieces here. I'm going to use this and I'm going to put it to the ground strip. Okay, so now we need two 220 ohm resistors. These are called 1/4 watt resistors as well. That's how much, they don't dissipate a lot of power in this project, so 1/4 watt is absolutely fine. We're going to put one on that pin 5, and then we're going to take a wire and put that to +5 volts on the Arduino. So there's a little pin marked 5 volts. Okay, put that there. And then the other side is going to go to the other leg of the resistor. We'll take a second 220 ohm resistor, and that's going to go between pin 5 and the TX pin. So TX stands for transmit. These are the serial pins on the Arduino. We are going to transmit serial data from the Arduino through that resistor to that pin. And we'll take a piece of wire, go from the other end of that resistor, and go to the TX pin. Okay, there it is. It's a little messy, but we're doing this real quick just to as a proof of concept. So now we get to the important part, the code for our project. Here it is. I wrote it all out for you, a custom program. I called it BigSky MIDI Remote for Arduino Nano. So also, before we upload the program, we're going to need to make sure a couple of libraries are installed. So you see these two include statements, MIDI.h and bounce2.h. So these are libraries. So that's some additional code that my program relies on to run. So to check your libraries, go to Sketch and then go to Include Library. And if you scroll down, you can see I have those two, Bounce2 and MIDI library installed already. But you may not. So what you have to do is go to Manage Libraries, and you'll get the Library Manager. Now to find the libraries, if you search for Bounce, you'll see Bounce2. You can see I already have it installed. If I didn't, this install button would be lit and you could press it to install the library. Next, do a search for Arduino MIDI. And you want to find this one, MIDI Library by Francois Best. And once again, I already have it, but click this install button and it will install it for you. Once you have them installed, restart the program and you should see the libraries show up on the list. So to get this program properly, you're going to need to go to Tools and make sure you set up your board. So you're going to go to Arduino AVR boards and select Arduino Nano. Now here's a weird little thing. When you select Nano, depending on the board you got, if you got a real Arduino Nano, you would select this guy, Atmega 328P, as your processor. But if you got a knockoff, a cheap one, which I get a lot, you may have to select 328P old bootloader. All right, and this one is a cheaper one, so I have to select that. So that's one thing to keep in mind. You want to plug in your Arduino USB cable into your computer, and you should get a COM port that comes up that tells you which COM port it is. So my computer detected it and put it on COM 3, so make sure that is selected. And here is the code. A couple of things you can change very easily. So I have it on MIDI channel 1. Of course, there's 16 MIDI channels, 1 to 16. If for some reason you need it on a different channel, just change this number in the code. So if you need it on channel 7, put it on 7. Also, you can easily change this. Now, there's a thing I programmed in called auto reset, and I'll show you what that is when we demonstrate this. But what it basically does is when you hit the mode button, once it changes modes, it's going to auto turn off the effect, because I thought that might be important. I'm not sure how you use it, but yeah, say if I'm on the first mode and I turn it on, then when I go to the second mode, it's going to turn the effect off, because I don't know if you want that effect to carry on. If you want that to happen, leave this as 1. If you don't want that to happen, set it to 0 before you upload, and that will turn it off. Also, here are your MIDI CC values that you gave me. So the mode value is 70 and the on-off value is 97. And I just programmed it exactly like you said, 0 and 127 for one of them and 0 and 1 for the second one. And you can see all that basically happens down here. So you can see where the MIDI is being sent out. Here's our mode CC number. We're sending 0 on whatever MIDI channel you selected, or else we're sending 1 on whatever MIDI channel you selected. And for the other switch, we're sending 0 or 127 on the on-off CC number. Okay, so once you've got everything set the way you want, make sure your board is correct, and then go to upload. And what you should see is these lights, the RX and TX lights, kind of flash as the code goes through. Right now it's compiling the sketch. There you go, uploading. We get a little flashiness, and we're done. When it says done uploading, you should be good to go. So in order to test this and make sure it works, I'm going to use this. This is a 5-pin MIDI interface for my computer. This is the MIDI Man Anniversary Edition M Audio. I've had this forever. It works like a charm, and it looks very nice too. So we're going to take a MIDI cable and go from our project into a MIDI in jack. Next, to check things out, I'm going to use a program called MIDI Aux. And this is what we call a MIDI monitor program. You want to make sure your MIDI device is set correct. There's our MIDI Sport in, okay. Okay, so now the MIDI monitoring software is listening to our MIDI port. So if I push the on-off button, you can see there's 97 at a value of 127. So that should turn it on. If I push it again, and also notice the LED came on, right? Push it again, and it will send 97 at a value of 0. So that should turn it off. So you click it on, your effect is on, held, and then it will stay on until you push it off. The second button is the mode. So if we push it, all right, there's our mode change command. So we've got 70 and our value is 1. So that will select one of those two parameters. If I push it again, now it's going 70, 0, and that will select the other parameter. And if I push it again, I'm back to 1. Now, if you notice also, I'm doing a 97, 0, which basically turns the effect off. That's that parameter, that auto off parameter that we set. Remember I said you could select that as either being on or off. So if you look what happens, if I turn on the effect and I go to the other mode, it's going to turn it off. Right? Once again, turn on the effect, switch to the other mode, it's going to turn it off. Like I said, if you don't want that, change it in the program before you upload it. But there you go. I think that's exactly what you were looking for. I don't have a BigSky pedals to test this on. They're a little too expensive for me, but I believe that should work. It looks like it's giving us the right output. To test the external power option, I'm going to take a little power adapter. This is a 9-volt power adapter. And if I look on the front, there's a little symbol that tells me the pin is positive and the shield, this outside part, is ground. So what I like to use to test things are these little, I think they're security camera adapters, and they basically have the jack on one end and 2 screw terminals on the other. I just attached a couple of wires. So the shield one is ground, so I'm going to attach that to my ground strip anywhere I want. And the power pin, we're going to go to the pin labeled V in. And on a nano board, the V in pin is what we call a regulated input. So it's going to take whatever voltage you give that within reason. 9 volts is a good voltage, and it's going to cut it down or regulate it down to 5 volts that our circuit needs. So there you go. We will plug in our adapter. And there you go, everything lights up. Let's reattach our MIDI. I like to detach things when I'm playing around with power supplies. And if we look at our monitor, there we go, it's working. And that's the whole circuit. Notice I removed the USB cable. You don't want to power it externally and via USB if you can help it. So there you go. I think this is the circuit you need. Give it a shot. Let me know how it goes. And hopefully we just made your dreams come true. So there you go, Hank. I hope this video helps you out and all your dreams have indeed come true. If this video does well, maybe we'll do this as a regular segment. If you want to make my dreams come true, make sure you hit that like button and subscribe, and maybe we'll see you on a future episode. But before we go, I got to give a shout out to the people who really make my dreams come true, my patrons on Patreon. So let's put their names on the screen and give them a big thanks. Thank you guys. See you next time.